Well, in the old days, I used to sit them outside, and outside meant outside, right? So, okay, here we go. 429. It's a pretty easy day today. I think you'll find it's pretty easy. I want you to understand why it's easy, though. So our objective today is to find sine and cosine. I think I'm doing theta and tangent. Cosine and tangent of theta from the unit circle. Okay? So let's go to what we know. So what we know is sine is the opposite of the hypotenuse. So if I just draw a triangle real quickly, right? Put theta here. So now we're going to start putting triangles into the circle. And you'll see how it works. It's actually kind of cool. We know that if sine is opposite over the hypotenuse, right? Since it's the unit circle, the radius is 1. Right? So in the unit circle, the hypotenuse is 1. That's convenient. That's why we like the unit circle. That's very convenient, so we got the number 1, which is real easy to work with. The opposite is a corresponding y value, right? If you graph a point, you go over, which is next value, and up. Then the opposite is the y value. So the sine of theta, which is the opposite over the hypotenuse, is the y value over the radius, but in the unit circle, it's just the y value of your point. Cosine's the same way. Cosine of theta is the adjacent over the hypotenuse, but in the unit circle, because the radius is 1, right? That makes the hypotenuse 1, because the length of the radius is 1, which is the hypotenuse is 1. And the adjacent is the corresponding x value, right? I mean, if you're a graph point, you go over and up. So in any triangle, then it's the corresponding x value, which means cosine's just the x value of your unit circle. And then tangent, which is the opposite of the adjacent, is going to just be the opposite is the y value of a point, and the adjacent is the x value. It's just going to be the y over the x. Okay. Now, you have your unit circles out, right? Let's add some things to our unit circle. It's on a coordinate. Even though the graph is technically on graph paper, I made it super big because we want to put things on there, but you know, technically we're looking at something this big, right? Are you guys with me? But we made it big enough so we can add some things on there. So I know the coordinate of this point. Let's start putting points in, okay? And let's see. I like colors. You don't have to use colors, but I like colors. So this is my coordinate of 1, 0, okay? This point up here is the point of 0, 1. This coordinate would be the coordinate negative 1, 0. Come on, pen, don't die on me when I need it. Well, let's see. I don't know if I have another blue pen, but I've got blue. I have blue. There you go. And then the coordinate down here would be the coordinate 0, negative 1, okay? How am I doing? Okay, so I got all those in there. So we can do trigonometry from the circle. We really can. So for instance, let's go back to this. You got your circle in front of you, right? Sine of 90 degrees. Now let's think about this. Sine is the y value. Oops, sorry. Sine is the y value. That's what we said, that the sine is the y value, okay? So I look at my circle. I go to 90 degrees. What's the y value of my point? What's the y value of my point? 1. Okay, so just to be fun, sine 90. Wow, we're smarter than a calculator, aren't we? Whoa. Cosine of 90. Cosine of 90 is the x value. So I go to my unit circle, I'm at 90 degrees. What's my corresponding x value? 0, right? Cosine 90, guess what we're going to get? 0. Because as an x value, it has to be 0, right? Tangent of 90. Okay, so tangent 90 is going to be my y over my x. So my y value is 1. My x value is 0, right? Okay, I don't even need to calculate. I know there's something really bad about that. Do you remember Cookie Monster? Remember what happens when you divide by 0? Bad things happen, so it's undefined. Let's check it out. Oh, clear. Tangent of 90. I'm not very happy, right? Cookie Monster has no friends. You can't divide by 0, right? Sine of pi. Now we're in radians, so sine of pi. So I go to pi, and I would need y. The sine is my y value, right? So I go to pi, which is right there. What's the corresponding y value? 0. See this works? It's just 0. And again, I can also use my calculator, but I got to change. Now here's the thing. You can use your calculator. If you're going to use your calculator, you have to change your mode to radians. First time we've looked at that, right? We're using the other angle. So we change our mode to radians, and then I can go sine of pi, and I get an answer of 0, which is easier from the unit circle. You agree with that? Cosine of 2 pi, cosine is the x value, right? 2 pi is there. What's the corresponding x value? 1. So it has to be 1. And again, I could use my calculator, but it's faster not to. I can go cosine of 2 pi. I know the answer is 1 because my circle verifies it. There it is, 1. Okay. Tangent of pi. Now tangent is my y over my x, right? I go to pi. It's my y over my x, which is 0 over negative 1, which is 0. And again, if I want to verify it, I can go to tangent of pi and 0. So it corresponds, right? But it's so much easier on the inner circle. Now, sine of negative pi halves. Okay, here's a rotation. Think about rotation. It's a y value. But think about a rotation. Okay, on my circle, pi halves is here. Think about a rotation. So negative pi halves is to rotate the opposite direction. Negative pi halves is here. Let's show it again. A rotation of pi halves is to here. Then a negative pi halves rotates it to here. Okay, so we're at this angle. If we want the sine value is my y value here, which is negative 1. I can verify it on my calculator if I want to. Sine of negative pi halves is negative 1, okay? Cosine negative pi. X value, because cosine is my x value. And it's a rotation, but you're going to wind up in the same spot anyway. So I can rotate all the way to pi, right? I can rotate all the way to pi, or I can rotate backwards the same rotation, which still puts me in the same spot, right? So I'm right here, and I want the x value, because I want cosine. The x value is negative 1. Again, I can verify it on my calculator if I wanted to. Cosine of negative pi, and sure enough, I get negative 1, okay? Tangent of 3 pi halves, okay? It's a rotation. Okay, you ready? Watch. Everybody watching? I want to go negative 3 pi halves. Negative 3, I'm sorry.
Just negative 3 pi.
Negative 3 pi. Thank you. Down, you're right. So ready? Watch. Going backwards, negative. I'm going backwards. 1 pi. 2 pi. 3 pi. Want me to do it again? Pi is this much, but we're going backwards. 1 pi. 2 pi. 3 pi puts me at this angle here. And so I want the tangent, which is going to be my y over my x, which is going to be my 0 over negative 1, which is 0. And again, I can verify that with my calculator 1 or 2. I can go tangent of, whoops, back up, of negative 3 pi, and I get an answer of 0, okay? What do you think? Thumbs up? Not too bad, is it, right? Unit circle is kind of cool. I like it. Okay, now, turn the page. Okay, name the quadrant. What does that mean? Well, let me go ahead and just draw a picture. Quadrant is 1, 2, 3, and 4. Name the quadrant. So sine is my y value, okay? This is not hard. You guys are smart. Sine is y value. So if it's positive, it's up here. Okay, positive y is up here. Does that make sense? So it's up here. So that's in quadrants 1 and 2. Positive y is up, correct? Cosine is my x value, but this is going to be a negative. So cosine being the x value is negative in quadrants 2 and 3. So we have an angle that has to be up in these two quadrants and back, so it narrows it. It has to be in quadrant 2. Want me to do that again? Okay. If it's y value positive, it's quadrants 1 or 2. If it's x value negative, it's in quadrants 2 and 3, which means it has to be in quadrant 2. So my answer has got to be in quadrant 2. Okay. Now let's do the opposite. Unit circle. Cosine is my x value. So we need an x value of negative 1. What's the angle? X value of negative 1. Okay, look at my unit circle. X value of negative 1 is right there, isn't it? There's my x value of negative 1, so the angle is pi. You can give me 180, but we're not babies anymore. We're not going to use degrees anymore. We're going to use radians. So it's got to be theta is going to be pi radians in radians, okay? Tangent. So we're looking for a y over an x that equals 0, okay? Which really means that the y has got to be 0, which really means the y value is going to be 0, okay? 0 over 1. So where is the y value 0 on the circle? On the circle, where's the y value 0? Well, happens here, and it happens here. It happens in two places, okay? So it happens at 0 over 1, so it happens at 0 radians, and it also happens at here, 0 over negative 1, and happens at 0 over, up on 0 over negative 1, so it happens at 0 and at pi. Now, one question, one thing real quickly. So, this spot right here, everybody watching this spot right here? Watch. You don't want to count it twice. You're going to call it 0 radians, not 2 pi. Does that make sense? It's the same angle, except for you'd have to rotate all the way around to get to it. So we're going to call this angle right here 0 radians. Okay, like 0 degrees, not 360, right? Which would you have? 0, not 360, okay? Sine and negative 2. This is a trick question. Sine is a y value. Sine is a y value. So I need a y value of negative 2. Y value of negative 2. Y value of negative 2. Here's negative 1. No such thing. Do you see that? Here's negative 1. Is there a point of -2 on the circle? No way, it's not on, it's in like Foreverland, right? And so, no angle. In fact, if you did sine inverse of -2, what do you get? Error, doesn't like it. Okay, now, example 4, almost done. So, the thing about the unit circle is the radius is 1, right? This is not on the unit circle. I know that already. This is not on the unit circle. I know it's not on the unit circle because the radius does not equal 1, okay? Because I got the -3 and the 4. Those are much bigger numbers than 1. So let's find the radius, okay? So first of all, let's find the radius. So let's find R. Well, we've been trying, or at least I've been trying, to get you to put triangles inside the circle, haven't I, right? And if I were to draw a right triangle in this circle, then the right triangle I have looks like this. Okay? Just superimposed. Okay, I took this little right triangle here. This length is 3. This height is 4. Okay, because to make this, I'd go back 3, up 4. But if we want to use Pythagoras theorem instead of calling it -3, it's a length, right? So let's find R, or a squared plus b squared equals c squared. Wait, let's write it better. X squared plus y squared equals r squared. Same formula, except for since we're in coordinates, let's use x, y, and r instead of a, b, and c. Same formula, but we're talking about an x value, y value, and an r value. So 3 squared plus 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. Square root, r equals 5. Okay, well, I needed that. You know why I needed that? Because the notes I gave you today said that sine of theta is equal to the y over the r. And the notes today I gave you said that the cosine of theta is equal to the x over the r, right? So we want sine of theta. My y value is 4 and my x value is 3. Yes. Isn't this cool? The unit circle, all the trig, I love the unit circle because it explains trig. It really, it tells us why trig works. So then, the y value is 4. So my answer is sine of theta is going to be 4, and the radius of this is 5, right? And the cosine of the angle, down, you made my day, is the x value, which is -3, over the radius, which is 5. Pretty cool stuff. I get excited about the unit circle. I like trig. Okay, so let's look at it